Hi, welcome to today's lesson. Our learning target today is I can convert or turn Hi, welcome to today's lesson. Our learning target today is I can convert or change a decimal into a fraction. Hi, welcome to today's lesson. Our learning target today is I can convert or change a decimal into a base 10 fraction and a base 10 fraction into a decimal. Now, a base 10 fraction, as you'll learn, is simply a fraction that has a power of 10 in the denominator. Recall, powers of 10 are numbers like 10, 100, 1,000, and so on. But let's learn more from Rob right now by watching this lesson together. I'll pause periodically to talk a little bit more or add some information. Let's get started.
Now that we know the basics of how decimal numbers work, let's see how we can write some special fractions using decimal numbers. I'm going to call these fractions base 10 fractions because their bottom numbers are all powers of 10, like 10, 100, or 1,000. Let's start with this fraction, 1 over 10. Well, you should recognize that it's one of our building blocks, and this should be easy to write down as a decimal number because we have a number place just for counting tenths.
Before Rob shows us what this number looks like as a decimal, I want you to think of it first. Visualize in your head what you think 1/10 looks like as a decimal number. Now, let's compare that image to what Rob's about to show us.
So all we have to do is put a 1 in the tenths place, like this, 0.1. Now when you write decimal numbers, it's important that you always include the ones place. But since we don't have any ones, we just put a 0 in that spot. The 0 makes the decimal point easier to see.
That 0 does something else too that's really important. It reminds us that this particular number is less than 1. In other words, it represents a fraction.
All right, so that's 1/10. But what if we have 2 over 10 instead? Well, all we have to do is change the digit in the tenths place to a 2. So 2 over 10 equals 0.2. In fact, we can keep counting tenths like this. 3 tenths, 4, 5, 6, 7, 8, 9, and finally 10 tenths. But look what happened when we got to 10 tenths. Now we don't have a digit for 10, so we had to use the next number place over, the ones place. But that makes sense because if you have the fraction 10 over 10, that makes a whole, and the value is just 1. Of course, we don't really need the 0 in the tenths place to write 1, but as long as the decimal point's there, at least we won't confuse it with 10. All right, tenths are pretty easy, but what about hundredths? Let's start with the hundredths building block, 1 over 100. To write that as a decimal, we simply put a 1 in the hundredths place. We also need to put a 0 in the tenths place to act as a placeholder and show that we have no tenths. And we still need to put a 0 in the ones place as usual. Next, let's try 2 hundredths. For that, we simply put a 2 in the hundredths place. Let's keep on counting with hundredths just like we did for tenths. 3 hundredths, 4, 5, 6, 7, 8, 9, and 10 hundredths. But look what happened when we got to 10 hundredths. Just like before, we have to use the next number place to the left, the tenths place. This happens because any time you have 10 of a building block, they combine to form one of the next biggest building block. For example, 10 hundredths is a tenth, 10 tenths is a 1, 10 ones is a 10, and 10 tens is 100.
Now, that's Rob just telling us the pattern that we learned in a previous lesson in a new way. And that pattern is, as you move from one decimal place to another, from right to left, the place values represent amounts that are 10 times larger than the previous place value. So if you start with the ones place and you move to the tens place, well, the tens place represents an amount 10 times bigger than 1, right? And 10 is 10 times bigger than 1. That makes sense. I just wanted to point out that Rob is talking about something we already know. He's just saying it in a slightly different way. All right, let's keep watching.
Now the next fraction after 10 over 100 is 11 over 100. Now if you think about it, you'll see that 11 hundredths is really just a combination of 10 hundredths and 100. Knowing that will help us write it as a decimal. Because a group of 10 hundredths is equal to 1/10, we put a 1 in the tenths place. And we still have that 100th left over, so we put a 1 in in the hundredths place. There, 11 over 100 is just 0.11 as a decimal. Fortunately, you don't have to break up the fraction into tenths and hundredths each time. Anytime you have a two-digit number over 100, all you have to do is put those digits into the tenths and hundredths place of your decimal number. Let's look at a few more examples to help you see the pattern. 24 over 100 would be 0.24. 32 over 100 would be 0.32. 78 over 100.
What would 78 over 100 look like as a decimal? Answer that question now. Let's see if you're correct.
Would be 0.78. And 99 over 100 would be 0.99. Now, what do you think will happen if we convert the fraction 100 over 100 into a decimal?
Go ahead, answer that question right now.
Right. 100 has 3 digits, so we need to use another number place. Now, the next one over is the ones place. And that makes sense because 100 over 100 is a whole, and its value is just 1. Now that we know how to convert hundredths into decimals, let's try converting thousands.
Now, Rob's going to do the same thing he just did. He's going to show you how to convert thousands starting with 1/1000th, and then he's going to give you a whole bunch of examples. And towards the end of those examples, I'll ask you a few of the questions too.
That's fractions that have 1,000 as the bottom number. Let's start with 1 over 1,000. Now this should be easy. All we have to do is put a 1 in the thousandths place. Notice that this time we need zeros in both the tenths and the hundredths place to act as placeholders. Next, let's try converting 10 over 1,000. Remember that 10 thousandths is the same as 100, so we'll put a 1 in the hundredths place, and we'll put a 0 in the thousandths place. We don't really need the 0 at the end, but it helps us see that this was 10 thousandths. All right, what if we have 100 over 1,000? Now that's a 3-digit number on top, so we're going to need to use 3 number places: the thousandths place, the hundredths place, and the tenths place. So as you can see, 100 over 1,000 is just the same as 1/10. Let's see a few more examples. 58 over 1,000 is 0.058. 73 over 1,000 is 0.073. 365 over 1,000
is what? What will that number look like as a decimal? Go ahead and answer that question right now.
Is 0.365. And 999 over 1,000
looks like what? Answer that question right now.
Is 0.999. And finally, what do you think we'd get if we converted 1,000 over 1,000?
What do you think we'd get if we convert 1,000 over 1,000? Does that look familiar?
Right again. 1,000 over 1,000 is just a whole, so its value would be 1. Okay, so we've learned how to convert base 10 fractions into decimals, but we can go the other way too. We can start with a decimal and convert it into a fraction. Let's say we want to convert a decimal number into a fraction. All we have to do is take the decimal digits and make them the top number of a base 10 fraction. The bottom number will be determined by the smallest number place used in our decimal. For example, to convert 0.8 into a fraction, we put an 8 on the top and a 10 on the bottom because the smallest number place in our decimal was the tenths place. And to convert 0.29 into a fraction, we put a 29 on top and we put a 100 on the bottom because the smallest number place in our decimal was the hundredths place. And finally, to convert 0.568 into a fraction, we put 568 on top and 1,000 on the bottom because the smallest number place in our decimal was the thousandths place. Okay, so far, all of the fractions that we've converted to decimal numbers, and vice versa, have bottom numbers like 10, 100, or 1,000. Those fractions are easy to convert because our number system is based on powers of 10. We have number places specifically for counting those. But what if we want to take fractions with different bottom numbers, like 1/2, 3/4, or 8/25, and write those as decimal numbers? We don't have special number places for halves, fourths, or 25ths.
Whoa, Rob. Slow down. That is a subject of another lesson. We're going to end today's lesson right here. So you're going to practice converting decimals into base 10 fractions with 10, 100, or 1,000 in the denominator. And you'll see some fractions with 10, 100, or 1,000 in the denominator, and you'll turn those into decimals. We're going to go both ways today. Let me know if you need help. And remember, today's learning target is I can convert base 10 fractions into decimals, and I can convert decimals into base 10 fractions. All right, let's get started.